Maybe there's something else. Is it better now? Yes, it's a lot better. So, okay, so it's just the sound. It looks like for some reason there's some weird part with OBS. It doesn't want, so it changed the input for my microphone that I have just in front of me, and it moved to something else. Okay, so let's go back to that. So welcome. So I've been talking. So let's go back a bit. So welcome and thank you for joining me for the stream today. So every week I'm talking about Uno and .NET and developing on the Uno platform. So adding lots of things around bug fixing and talking about new features. And we've been quite busy for the past week or so, for the past months or so, but with the team with providing for the newest updates that's going to be released in the next few days. So Uno 3.5, stay tuned for that, and that's gonna be fun. So now so that was what I was talking about is the update for what we did last week, which is talking about the package-based path for the resolution of single file packaging. So you can build an application using a single file, and so that update actually did the trick. So the idea is that instead of using the assembly.get entry assembly, we can now use app context.base directory. So that means that when the application is packaged as one single file, then the resolution works properly, and then we get the proper path. And if that doesn't work, because it's used in many places, if it's used in many places, that means that fonts and images will not be loaded properly. So now that works properly. So if you get to the latest and soon to be the 3.5, you're going to get an update for that one. So today we're going to be talking about one interesting thing, which is something that Matthew Leibowitz has been doing. I don't know if he did something about this recently. Not that recently, but there's he created an application that's called SkiaSharp Fiddle, and the idea is that you have some C# on an editor, and on the other side you have the result of that running on the side. So in your applications, and you can change the content right away and see your results without having to do anything. But to be able to do that, we need to be able to actually compile some code and execute it. And what I want to have is the ability to run that, not necessarily locally on a native app, on a desktop, but I want to be able to run it inside of the browser, and that's something that is available. So let's take a look at this. So a while back, so now, and the reason I'm talking about this is that quite a few things have been happening with .NET 5, and the changes is that I did a while back an application that's actually this one. This is an application that on the side you have some C#, and then if you click the execute button, it uses an embedded C# compiler, and then which creates a .NET assembly, and that .NET assembly is loaded up inside of the browser. So when I compile, if we can take a look here, there's nothing that goes out to the network. Everything's run completely locally. So that specific binary here works using .NET, so something that's similar to .NET 4.5 or 4.7, which is using the mono runtime, an explicitly mono runtime, so not .NET 5. And what we're going to try to do as a first step to be able to run some Skia directly in the browser using some code that we write in the browser is to try to get some C# code compiled and run inside of the browser, but using .NET 5 this time, or actually .NET 6. And a while back, I had a sample that was doing just that, and it is an application that I had as a sample. So it's basically a simple application that's not actually an Uno application. It's using the Uno bootstrapper, so it's just a static main, and it uses Roslyn explicitly to compile, parse. So we can see here. So we could create a compiler. We're adding syntax trees, so that are coming from this compilation unit here, and then we're doing some get metadata here to get some symbols to see if that works, and then we're emitting an assembly, and once that assembly is emitted, we can load that assembly, then try to find the program in it, so the actual program that's specified at the top here, and then we invoke the main, and the main is going to be saying inner hello. So that's pretty much what the base of the sample does, and that is still using .NET standard 2.5. So .NET, actually, I think I probably tried already to try to make that work, but it's probably didn't at the time. So we're going to be trying to make that work again. So it was using at the time .NET standard 2.5, and now we're going to try to make that work in .NET 5. So it's actually using a custom version of the bootstrapper. So let's try to make that work right away. So we're going to be updating the bootstrapper and dev server to a more recent version that's coming from NuGet. We actually published a few updates just today, so that one is probably too early. Probably going to need to change explicitly the version numbers. So I'm sometimes installing explicitly pull request builds, so I can just check out if something does work properly with something that comes out of the build of the CI directly. But let's take a look at this one. So it's dev 163. Let's update that. So I'm just updating one manually. I'm just going to change the other manually here. Okay. And Microsoft Code Analysis, we're going to be using the latest one, or close to the latest one, which is, I think it's 3.9, but let's go for 3.8 for now. So 3.8.0, which is close to the one that was released when C# 9 got out. So 3.9, I'm not sure exactly what's in this one, but I'm probably going to have to figure that one out at some point. Okay, so what we're doing here is basically building the application, and to be able to make that run properly, what we're going to do is take a look at the structure of this. So to be able to compile something, Roslyn needs the assemblies, and it needs a lot of assemblies, actually all of the assemblies that are available. And in the context of the application running here, we need to provide the assemblies to the application running inside of the browser as part of actual files, without any linking, without any linker running or any other parts of that. So that's why there's a folder here that's called Mono SDK that contains all the assemblies of the .NET SDK. So I'm not sure about which one those are, but we're probably gonna have to update those to a later version. And once those files are put there, they're put there as embedded resources. And what we do is we get those files and we extract them one by one so that they're available to the application running. So I'm just going to take a look at how we're doing this. Yes, so what we're doing here, so when we're instantiating the iLanguage service here, we're extracting all the files that are in the Mono SDK folder that have been put in embedded resources, and write them, actually provide them as references. So it's references that are automatically created from streams. So we provide them completely to the compiler so that it can compile something that can be executed inside the browser. So let's build this and see what that does. So the point of the exercise here is to be able to take a .NET 5 WebAssembly runtime, embed it the Roslyn compiler, and see see if it's able to compile something. So let's try to do this. So the failure at this point is that it doesn't know how to resolve SQLite PCL core. For some reason, there's something like that. So so that may be something that comes from .NET here. So the interesting thing is that those dependencies are coming from the Microsoft Code Analysis itself. So it has a dependency on SQLite PCL raw core for some reason. So what we're going to do is disable the compiler, the linker for now. So if you've been following me for the past weeks, you're going to see that something is available there. And for disabling the linker, so you can search for the linker in the Bootstrapper repository. So we're taking the WASM linker here. We're going to put that in the net5. So we disable the linker and see how far we can go. So let's try to rebuild again. So it's better a little bit. So now it says that it doesn't resolve. Okay, so that's something different. So that means that for some reason we're trying to resolve this, and it's part of, it could be part of this. So if it doesn't work, we're going to try to add SQLite and see how far that goes. So luckily we've been making some modifications for that recently. So let's try to go and take a look at that. So it's Uno SQLite, if I remember correctly. We have the SQLite provider for WebAssembly. So let's install that one. So restore failed. Did it install properly? Let's take a look. Yes, it installed. So let's see if we rebuild, if we have something that's working better. Hello, Ixtagon. We're trying to do some Roslyn and Skia. Well, it's Roslyn first, and then if it works, then we're going to do some Skia afterwards to replicate the behavior of the application that Matthew Leibowitz has been doing to do, C# on one side and the result executing in the application directly. So let's see. So it's running better. So it's still doing something here. It's likely that it's the linker, maybe, I'm not sure. So I'm wondering if it's something that we probably need to take a look at. So this one it's running using SQLite. So that's why it's running. So you can see it's called .NET here without a command line. So that means that it's running under Ubuntu. So the reason for this is that it's actually linking the SQLite. It's linking the SQLite runtime, a native runtime. So you can see here, it's actually probably already done. So it's that one. So .NET is not here. Oh, .NET's done. That's why. Okay, so it's finished. So it failed because of SQLite batteries v2. Okay, so that's something else. So let's go take a look at another sample that I built a while back. So that's one that uses SQLite. So we're going to be opening that one and see if there's some additional dependency that could be added there. So here's the SQLite sample. And let's take a look at the dependencies here. So that sample, I don't know if it's been updated to .NET 5, but maybe. So is it .NET 5? No, it's still that standard 2, but no, let's take a look. Let's take a look anyways. So there's SQLite here, and there's the SQLite provider WASM. So it's the same version here. Okay, so it's probably something else. So if we go back to our Roslyn test here, the reason for this is that it's trying to take a look at that one, which is SQLite batteries v2. So this is something that AridSync has been provided. It's a bit difficult to understand. There's quite a few dependencies there. So what we're going to take a look at is where that assembly comes from. So let's go to NuGet and see if we can find something around that package. So there's SQLite row, not just row. There's the core one, there's the bundle green. So it could be a dependency that's not that useful. But because it's detected by the dependency system, it may not work properly. So okay, let's try to add one and see where that goes. We're trying to add the missing dependency so that that the packager for WebAssembly is able to run properly. So let's go for that one. So does it install? It says, yeah, it did install. Okay, so let's see if it's a bit better. So let's take a look again at what's executing here. So you can see here that the packager is running. Nope, not top, it's watch. So we got the packager that's running. That's the one that's taking a bit of time at the beginning. And then we're gonna see if it does something different there, if it finds the missing assembly. So when we're talking about missing assembly, so the idea is that when we take a look at the output of the application here, if we take a look at the input, so we're not in release, I think, or in debug. That means that inside of all the dependencies that are available as part of the linker input here, so those are the files that are provided to the linker, and that means that there's one of those assemblies that needs the use of the SQLite something, SQLite PCL or raw something that the packager is trying to determine the availability and fails to do so. So we're going to see if that one changes a bit. So if we can probably take a look, so we can try to find that one out. So I know that they've made updates to Roslyn recently to improve the performance, and they've added dependency. They've added a dependency to SQLite. So that improves the performance of some lookups that are done internally. Not sure exactly which ones. And maybe if that doesn't work, you can probably go back in versions and see if there's another one that may be of interest there. So it's not that one. So maybe it is that one. Let's see. Is there a dependency in SQLite here? There isn't. Okay, so that probably is another dependency that's not available as part of the end result of the compilation. So we're probably going to be looking at that. Okay, no, it's not that one. Okay, it's still building. Okay, so if it's still building, it's probably taking a look at EMCC. Okay, so that means the linker passed. So that's good. So adding that bundle green kind of helped. So this is good. That doesn't mean that it's going to work, but at least this is a bit better. So I know that for .NET 5, we still have some work to do, and I'm probably going to be taking a look at that one afterwards. It's kind of deep, the rabbit hole, but gives some details about what's happening when doing some .NET there for WebAssembly specifically, and if there's something that needs to be updated to get that running on .NET 5. Okay, so it built. So let's run this and see what happens. Okay, so if we go to our console, okay, so that's pretty good. So we can see here multiple things. So the parsing of nodes work. So we can see that this is a syntax node that has been parsed as part of the program that was running here. Okay. So this is the parsing that's done here. So the idea is that we give the syntax factory, which is a class in a helper class of Roslyn, we give it some string that looks like C#, and it tries to parse it out. And if it doesn't fail, it gives you right back what you've given, but parsed this time. So we can do toString here. So it's a compilation unit syntax. So it spits it out untouched, but it gives something interesting. Now what we got is we got a symbol, which is good. So that means that this worked properly. Then we got a compilation, no errors. So the program that we've put here with the right line inner hello is actually compiling. So there's no diagnostics. We can emit an assembly. We got one, and then it fails with searching for MS core lib. So the reason this fails is that the assembly that are here in bundled with the application itself are actually part of the Mono SDK, which is not the right one. So this is not something that can run with .NET 5. So we need to replace all those files with ones that are coming from actually .NET 6. So now, because it's the runtime that's running there is .NET 6. So let's take those out. And I'm going to go to the temp folder and try to find the it's the .NET. Oops, sorry. Actually, let's take a look at. I think it's there. .NET runtime. So I'm not sure. So let's take a look at this one. It's probably going to be that one. So this is the .NET SDK, and so let's take those files, and we're gonna take the files that are coming from the runtime. So this is the files that are inside. So we get lib net6. So these are all the files that are part of the SDK for .NET, so .NET 6. And what we're going to do is take all those files and embed that as embedded resources as part of our small sample. So I'm going to take all of this except the symbols because they're not very useful. And so this one is coming from WPF, which is interesting. They got some dependency there because of that. And we're going to put that back to the folder that's called Mono SDK. So those files are coming from .NET 6. This is the exact output of the CI. And this is what we're going to be executing against, the compiling and executing against. The best is to have those files aligned with the version of the runtime that's executing the outer application. But since I've just taken I've taken the files and put them there directly, they're aligned already. Also, to be sure that it's the .NET, an actual .NET one, we have to have another file. I'm not sure, it's not there. Oh, it's a private one, so we don't need that one because it's a private implementation detail. So those files are included but not there. So those files are referenced by the other ones. They're part of the runtime, but we don't need to have those directly inside. So let's rebuild our application. So let's just take a look at this, make sure that we have the right files. Yes, we do. Okay. So let's rebuild this. Okay, so Mr. Nawashad has a question. How do I use the Firebase SDK in Uno platform? Mainly Firebase GeoFire. So this is not an Uno question per se. This is a Xamarin question. This is something that you can use. There's a Firebase SDK that's available for Xamarin Android and iOS only. And I'm not sure if it's available for macOS. It's probably something that needs to be taken a look at. But if you search for, I think it's Xamarin Firebase. Let's take a look at Firebase. Yeah, so you had Xamarin Firebase common, and those are, I think they're quite well documented if I remember correctly. So you can use those from there. Hey, Mr. Lama, fancy seeing you here. So we're doing some Roslyn for those of you that are joining. Who could have imagined? Yes. Yeah, we're gonna be taking a look at probably. I think it's going to be next week. We're doing some updates to the port of the well, not the port, but the fork of the Windows Community Toolkit, so that it targets the version 7 that's coming up, that the Llama here has been working hard on. So we're gonna reap all the benefits and make that work in Uno. So is it still building? Yes, it's still building. So let's take a look again at what the runtime is doing. So this is the packager running still. So if it works properly, we're gonna. I'm saying that I've been saying this for a few weeks, but there's something that's running there from the packager that's taking a bit of time that probably shouldn't, but maybe in the meantime we can take a look. So I'm probably going to be enabling the build logging here so that we see what's happening there. So you're using the Xamarin NuGets, but you didn't seem to have a NuGet for GeoFire SDK. So that I do not know, but I would encourage you to go ask a question on Stack Overflow and mention Uno platform there, and also Xamarin. And mention Xamarin, Android, and iOS, and there's probably going to be someone that knows about that, and we can help you there. So I'm not a robot. Oh well. Okay, so you can't search if you're a robot. So I'm a robot, so I'm not going to click. But you can go to Uno platform, and then you're going to get all that, and maybe someone has the answer for you for GeoFire SDK. I don't know personally. Okay, so is the build is finished, so that's good. So now let's take a look at what's happening at the runtime. Is our thing running properly? So fail to emit the assembly, predefined type system object is not defined or imported. Okay, so that would mean, so we got C, the compilation diagnostics is at 8. And that would mean that the assemblies are not aligned for some reason. So that could be that we're missing some assembly, and I'm wondering if it's that assembly that I was talking about that's not there, that may still be needed. So there's a different assembly that's in another location, and it's that one. So there's actually, for some reason it's placed here. I'm not sure exactly. I'm probably gonna have to take a look at that one at some point, but it's the core name, and that one contains quite a few things. And I think if I remember correctly, I think it contains object. The kind of, yeah, it contains the base of pretty much everything. So that means that because object is defined here, that means that there's no implementation to compile against. So we need that assembly to be part of our SDK that we have here. So let's update that SDK in the Roslyn test, and let's rebuild again. Okay, so I have the build logging enabled. Let's make sure that I also have the detail. No, let's go for diagnostics. So we can change the logging level of the build logging here by putting it to diagnostics. Now let's rebuild that again. So the point of doing this is that for some reason, there's some time that is spent in some part of the packager, for which I'm not sure exactly why. So we're going to try to find out, after everything's been run, after everything's running, why there's something that's spent in some time that's spent in the packager doing something. Okay. So yeah, so that's the idea. So when we're trying to building, and you can see here that the compiler is quite sensitive to the fact that missing assemblies, there are missing assemblies. The Roslyn assemblies are still working, but it's still missing. So what we're going to do now is we're going to assume that everything works properly, and we're going to make a new application So do we create a new one or do we create, yeah, let's go create a new one. So we can actually go back to it next week if time's available for that. We're gonna call that Skia, let's go Uno Skia Fiddle. Uno SkiaSharp Fiddle. So that application is going to be basically two sides. One we're going to put ski on one side, and the other one we're going to put the just a simple text block, just so that we can write some C# there, and that's pretty much it. It's going to be the base of the application. Okay, so let's do this. So we're going to be adding, so we're going to probably just remove most of those because we don't need them at this point. It's going to make it easier to take a look at. So we got the UWP application and the WASM application. The UWP application is probably not going to be useful either because for the execution, because there's no the Roslyn compiler cannot run in UWP. There's some missing APIs that prevents it from running properly. But let's do this. So we have our main page here, and we're gonna make it for. Oh, I'm using the preview one of Visual Studio, so that's why it's blank. So if you use there's actually a pretty good news there. Microsoft has been taking a look at the issues that we've been opening for a while, and the updates are that this is fixed. So this is not happening anymore. And there's also the fact that when you're inside of the, let's say you open the, let's close that one. Sorry, it was still opened, so it's still doing this. So you have to close it properly. It's good that it's fixed. Okay, so that works properly this time. Okay, so what we're going to do is we're going to split this in two halves. And so on one side, there's going to be a text box, on one side, and the other one is going to be a text box. So let's go for, we're going to make columns. I'm going to make two columns of equal sizes. For the first side, we're going to put a text box, and the other side, we're going to put a SkiaSharp canvas. We need to put it as the Skia namespace, and it's going to be using SkiaSharp.views, and that one is going to be on the second column. There it is. And let's go take a look quickly at our Roslyn sample. Is it finished? Yes, it's finished. Okay, so let's see what happens. Oh, this is nice. Okay, so what we do see here, so we're in .NET 5, or .NET 6, so .NET 5 project running on .NET 6 for WebAssembly that is using Roslyn to parse this string to compile it down to an assembly at runtime. We get the program type, we get the main method, and we execute that method, and it shows up in our hello. So that is very nice. So now we know that Roslyn can compile some C# code under .NET 6 on WebAssembly, and that the assembly that's generated can run in the browser. So that's pretty good. So that means that our proof of concept for the base can actually run. So that will probably be able to do something in the other application on the side to get something displaying some Skia directly in the browser. So let's do this. Okay, so the first thing to do is to actually add a reference to SkiaSharp. So let's add that reference to SkiaSharp. So that's pretty new. Now we can use the official ones. We can use the official Skia assemblies. in the browse. So SkiaSharp views.uno. So let's add that one. So the uno.skiasharp.views are now pretty much deprecated because there's the official version for that. So let's add that one. And so this one is actually using, if I remember correctly, Skia 88. So the latest and greatest versions that's coming from the latest version of Chrome. So Chrome 88. So now it's downloading quite a few things, installing the application. Okay, so it needs Uno Core. Okay, so we need to update a little bit of the content here. So it did not install. Yes, it did install. So we just, oh, that one's coming from UWP. Okay, so let's update that one so that the error message goes away. So it's 2.2, but we can use the dev version for that one. Okay, so that's that. So here's the application. So it's doing all the right things. So we could probably add that to, let's add it to UWP as well. So that we have IntelliSense working. SkiaSharp views UWP. UWP, I don't think there's actually one. I think it's just views. Let's add that one. Okay. So now if we go back here, we should be having example canvas. So it's probably, it may not be in there. I think it's probably in, yes, it's in UWP. Okay. Okay, so we have on one side our text block and the other one this example canvas, which displays nothing. And we have a method that's called update, if I remember correctly. No, it's not layout updated. I don't recall the name, so let's go take a look. The event is called paint surface. Okay, so let's do paint surface here. And on paint surface. Good. Yes, SkiaSharp. Yeah, it's pretty nice. Yeah, and Matthew has been very efficient at making all this working in very nice ways, even with his massive build pipeline. Pretty jealous about that one. Even the Uno one is not that complex, so that's pretty cool. Okay, so there's that. So we're just going to be doing a very small thing here. We're going to take the on-paint surface. So I don't recall the exact name for that one. So it's an event handler of SK paint surface. So let's do this. So it's called, I call it on paint surface. Object sender. Oop, sender. And it's SK paint surface event arg. And for that one, I'm going to take a look at the original example that I had in this repository, because I don't know the SkiaSharp API by heart. It's going to be easier that way. So we have here in SkiaSharp a small method that does, let's call this color here. We're just going to clear that. So the canvas, and the canvas is actually coming from, so it's arg.surface.canvas. Okay. And it's going to be SK colors. Let's put some yellow. Okay. Just to be sure that it works properly. We're just going to update that one to use .NET 5. And that should be it. Uno is the right version, so that should be enough. And we need to update the bootstrapper so it uses the version 2, which is the one that supports .NET 5. Okay. There we go, it's installed. validate that. Yes, 21663. Okay, so let's run the application quickly to make sure that it does what it's supposed to do, which is having a big yellow half of the screen rectangle. Oh, something that I probably need to do up front. Well, disabling the linker won't do anything there because we're using Skia, so it's enabled by default, so it needs to run. Let's take a look again. Yeah, there's the packager and all that, so that's pretty good. So in the meantime, what we're going to be doing is start to import the compiler itself. So we're going to make a small class on the side that pretty much imports what we have here. So we have multiple updates there from the C# language file. So let's take all of this and let's put that in some compiler file on the side. Let's call it compiler for now because I'm not sure exactly how that's going to be called. Which is going to be putting some files there. So we need to add the oh, it's still building. So while it's building, I'm not having anything. So we need to add the Roslyn package. So I can't do it right now. We're going to be adding that afterwards. And we're going to make a file. Let's do that. Oh, sorry, it was the other one. We're going to take this, which basically creates an assembly. So we got a syntax factory here. Okay, so it's called a compilation unit syntax. So basically, we're going to take a string. So we're going to take a string and return an assembly, pretty much. Okay, so let's make that class. So let's call that compiler. Let's make it static. Return an assembly, and it takes a string. There. So the build got canceled because I canceled it too early. The spell checking code fix provider is taking quite a bit of time. Not sure exactly why, but it's pretty annoying. It's probably using some external service that doesn't provide its response quickly enough. Okay, so let's do this differently. Reflection. So there's that, and so we said we need to add the Roslyn file. So we need to add this, the Microsoft Code Analysis. We need to add SQLite as well. So let's add all of this. Let's add all of this, and we're probably going to be needing to add as well the .NET SDK. So it's going to be part of those files. We're going to add that afterwards. So now we're saving. It's likely that IntelliSys is going to be failing again. Yeah, that's annoying. Okay, so let's take the directives at the top here because they're the same. Okay. It looks like it doesn't work there because we're on WebAssembly. So let's go back to WebAssembly here. Okay. So we get WebAssembly. We need system link as well. Okay. So we need a folder that's called, let's not call it Mono SDK. Let's call it .NET SDK. I'm going to copy the files that I put in there. I'm going to add those files to my applications shared folder here. Actually, no, I can't put them in the shared folder because it's going to make it difficult for adding the wildcards there. So let's not do that way. I'm going to put it directly in the WebAssembly project. Okay, so let's call it .NET SDK. And so we're going to have to take all those files and put them as embedded resources. To do that, we can use something that was in the other project, which is basically add this to the project so that all the files that are in the something to .NET SDK in the new project that are embedded as part of the original project. So there's probably someone that's going to say this, but if you do that, then your project is going to be huge. And you're right, it's going to be huge. So we're going to do it that way for this time, and we're going to be enabling that for the others afterwards. So let's change that name. It's going to be .NET SDK. So that means all those files are going to be part of the application as embedded resources. We can see here. So that works properly. And so it's not .NET underscore, it's not a dash SDK. So this is good. So now we can take the compilation here and actually compile something from the string. So if we go back to the sample here, we're going to take SkiaSharp language instance in memory assembly. We're going to take all of this for now. Let's not take the try catch for now. It's going to be useful for validating the errors. So we get this, we get the source language, so create a compilation. The SF syntax tree is not something that we can use right away, so we need to parse that using the syntax factory. So we need to provide that to the compiler. So let's do the same thing. Let's call it properly. It's a compilation unit, so it's a CUS. CUS is syntax tree, so we can replace that static string with something that we can provide here from compile here. Memory stream is system.io. Hi, Jose. Nice seeing you here. We're doing some Roslyn and Skia. So we're trying to compile some C# using .NET 6. I'm saying .NET 5, it's .NET 6, and we're going to try to mix all that with Skia and see what we can do with this. Okay, so that's good. So we have that running properly. So we can keep the right lines for debugging for now. This is not needed. Compilation diagnostics, we're probably going to have to write at some point, because if we are making, basically doing an IDE, very small IDE, but if there's a diagnostic error, we have to know what that is. If we write something that's not correct. Okay. So we got the binary assembly here. We can keep that one. So there we have the assembly, so we can return the assembly right away. Okay. And if there was a failure, we can throw something here. Yeah, washing the dishes. Yeah, that's that's something to do. That's for sure. Okay, so didn't work there. Let's write it manually. So it's not so. Let's do invalid operation. Invalid operation. I think I'm gonna go for the other Visual Studio because exception. Because IntelliSense not working is not particularly useful. And okay, so that's good enough. So I'm gonna close this and open it in the other Visual Studio because that one is not working well. And I'm going to use that one. So this is the preview 3. I hope there's going to be a newer preview up, because yeah, preview 4. And we're already waiting for 16.10, for which there's a nice update coming up. No Visual Studio. Okay. 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 No, probably was doing something else. Okay. So so there should be an update for this one, because it's using the other one. Roslyn test. Roslyn use SkiaSharp Fiddle. Good. Okay. So we got our memory stream here. We got all this, so that's good. Oh, preview 4 is available. What do you know? Got out just as we said it as we were talking about it. So what's new in it? Checking for updates. Okay, so got the language service that's missing. So let's see if the IntelliSense is running better. No. Why don't I have the language service here? Let's see. Where's that interface coming from? So it's coming from workspaces. Okay, so because I don't have the host here, probably. I do have it. Okay, so it probably would mean, oh, that's because I'm in UWP. That's why. Okay, so I have it now. So language service is good. We have the path here properly. We have an exception here. We can actually throw that exception directly. There we go. Okay, so that's good. So now we can go to the main page and let's see if we can actually build something that comes from the UI. So we have to hook ourselves up to, let's actually add a button below the text box. Let's add another grid. So we're going to be adding row definitions this time. Let's add a two row definitions. Except the bottom one is going to be, it's height. The bottom one is going to be auto. And so we're going to have a button that says content, compile, and let's do a click with the next bind on compile. And let's add that method. Probably going to have to add a name to the text box here. Source source.text. So this one is not going to be useful. So we can go to the compiler now. Compiler. And we want to do compile. I don't know if I did the right thing. Public static compile. Yeah, it's probably just a compile here. Compile our source. And we got our assembly here. That's it. And what we want to do is basically just call the paint surface with the code that's coming up from this. So what we're going to do is have basically some kind of a known entry point we're going to call it, we're going to assume that we have a type that's called program. That's good. Let's do that. Oh, actually, let's take a look at, let's take the same thing as the other one. We're going to say program here. SkiaSharp. No, it's not that one. It's that one. Roslyn test. We're going to take the program here. And we're going to do the same thing that we do here, which is get exported types. We're going to search for that specific type. We're going to search for that specific type in the assembly. And we're going to search for a method that's called paint. And so question from the llama. So you're using WebAssembly, not only because it's cool, but it is cool, but because you couldn't have called the Roslyn compiler call on UWP. Yeah, pretty much. It's because of the sandbox. Well, it's also because you can run it pretty much anywhere. But the idea is that because of the fact that the runtime is the UWP is preventing me from compiling something that runs on top of, I think the compiler now needs standard 2.1. So that's one of the reasons for which UWP cannot run that. But there's also a rest of other things like the fact that I think there's some parts of assembly loading that doesn't work properly as well. So I don't recall the exact details, but yeah, that's along those lines. But the sandbox of UWP prevents the compiler from running properly. Okay, so we got our method here, and what we're gonna do is basically provide it with, we're gonna provide it with an SK surface. So let's assume that we have a method. So we're going to take our paint method. Our paint method is going to be a delegate, and we're going to create a delegate of that one. Create delegate, and the type is func. No, it's an action. Sorry, it's an action of SK surface. And we're going to store that delegate as paint. Yeah, paint, something like that. So I have to cast it at the end. And let's add that as a field for our class. And what we're going to do is basically just do this. Paint arg dot surface. Oh, no more Visual Studio. Okay, no more Visual Studio. Okay, so let's do it manually here. And so we have a delegate for which we can provide it the surface, and then we just draw something. So that's it, pretty much. So the only thing that we need to do now is just add a default class there that will do something, because we don't have it. So we can take the default sample that I had at the top, so this one, and add it as a default of the source.text property. So let's add it that way. There's that. And our method here is supposed to be called paint. It takes so we have to add SkiaSharp.views.uwp at the top. So we need actually both those at the top to be sure. And it takes an SK surface. And then we can do what we did before, which is, and I lost it there, which is do a canvas.clear it's a surface dot canvas dot clear dot sk colors dot blue, so that it gives a different color than the one we have already. Oh. Okay. So it's text, obviously, because we're putting it directly inside of the application there. And there we go. And we need one last thing, which is we need to add Skia to the list of .NET SDK dependencies. And we'll see how far we can go with that. Okay, so this is, let's take a look at the option. I think because I built it once, there's probably already things available in the work AOT folder. SkiaSharp. So let's take those two and put them in the .NET SDK folder as well, because we're building code inside of the browser that needs Skia as well. So we need the compilers to know what to do with Skia. So it has to have the dependencies there. Okay, so that's pretty much it. So let's see what that does. So on paint surface, yeah, that should be it. So we're going to be doing something interesting afterwards. So there's Pete that's doing some IoT stuff, and Pete is going to be doing some interesting live coding for Raspberry Pi, and we're going to be probably rating his Twitch. So that's a new thing for me. So I'm going to be looking at the commands for rating Twitch. I know Mr. Lama, you know about all this, but I haven't done that already. So let me see. I think I have to do a raid somehow. Probably you should have taken a look at that afterwards. Oh, /raid, I guess. Okay, I'll try to do that. So, but in the meantime, we have to see if our thing is working properly. So it's building, which is good. Let's see where that goes for that one. So does it build? Yes, it raids. Okay. So we'll be able to do that pretty soon. So now that we have everything running, that means we should be able to next time do some more things, like add additional context to what we're doing. Yeah, it's SkiaSharp again, but it's not exactly SkiaSharp. It's a bit of Uno and a bit of Roslyn and a bit of other things. Is there any update on the timeline for a fresh getting started update? We're working on this to get some updates there. We heard the feedback loudly, so that's something that we're definitely looking at. So expect some updates, pretty soon. So it's taking a while to build, but I think we should be at the end. Let's see there. Still doing a bit of packager things. And if it doesn't work, we're going to be doing something different. But it's going to be for next week. So there. So still doing, oh, that's the linker again. Okay, so that's probably something that needs to be adjusted at some point. So we can see here that there was some time spent doing some analysis of some kind for all that time. So that's pretty long. That means that it's impacting the performance of the build significantly, because there are too many things to compile. So we can see quite a few things here. Still the linker running. Yes, that's gonna be it. That's gonna be fun. So there, still doing this. And still the linker. So the linker is still something that even the .NET team is complaining about it on itself, saying that it takes too long to build. So let's take a look at in the meantime, just a little bit until it finishes to build, what Matthew had for his features. So it uses Roslyn to compile. It uses WPF as the framework for showing up content, and it's drawing. So you get to set the size, and you get to set probably what I could think is the background color or something. Oh, yeah, that's pretty good. So I think we can probably manage to have that next time for the build. That's for sure. Okay. Oh, it finished. Okay, so what does it do? Does it start up properly? It does. Okay, so quite a few things that need to be adjusted. Okay, so we got something that compiled and it failed to emit the assembly. Okay, so it says SkiaSharp cannot be found. Okay, so that's pretty good. That means that next week, if you're still interested into taking a look at what that does, we can continue doing this and see how far we can go and mix all those things together and have some fun there. So yeah, I hope you had fun. I did. So I know I learned quite a few things, and knowing that Roslyn is able to run properly using .NET 5 is quite the news because it wasn't working before. So there were quite a few things that didn't. So now it does. So we can do some pretty interesting things. So until next week, have some fun with Uno and give me a follow. If you want to be notified when I jump online. So let's do some rating. See you next week. Oh, I cannot rate this one. Okay, so I cannot rate some other channels. So maybe I can run I can rate the channel from someone else. Maybe I can do the llama. Maybe you'll be online in a minute, so I'll probably rate yours, Mr. Llama. So yeah, it's I have to manage some to be able to do some more fancy things with that new Stream Deck that I have. It's probably just online. It's just for now. It's just about muting and unmuting, which is avoiding you to have some unpleasant noises. But probably rating and other things is going to be something that's going to be fun. So in the meantime, let's see. Mr. Llama. So what did we have there? If I can continue a little bit until Mr. Llama is available. There. So in here, we're missing a few things with regards to SkiaSharp for some reason, but I'm not sure exactly what. Let's find that out. Okay. Let's do this. And that's it. So have a good week and see you next week.